Hello, and welcome to this secondary snack. My name's Ian Davis, and I'm the Head of Curriculum at White Rose Maths. Today, I'm going to be looking at our Year 8 block, Angles in Parallel Lines and Polygons. Here are the small steps for this block. I'm going to be mainly focusing on this step, investigating the angles between parallel lines and the transversal. That's a key step for the understanding of the rest of the block. Also, I'm going to touch on how it impacts on this step, investigating the properties of special quadrilaterals. So here is the step. One of the main things I want to emphasize is the importance of the key vocabulary that we use and how we define and get students to understand these words. I'm also going to look at this key question, looking for the relationships and how they work if we move the transversal line, and that ties into this bit of the notes and guidance. The parallel lines should be varied. So firstly, how do we construct parallel lines? How do you construct them yourself? And how do you get students to construct a pair of parallel lines? Pause the video and have a think. Well, personally, more often than not, if I want a pair of parallel lines, I get a ruler, draw a line above it, draw a line below it, remove the ruler, and say they're parallel, relying on the manufacturer to have produced a decent ruler for me. The problem with that is that my pairs of parallel lines are always the same distance apart, and that can be misleading for students. If I want them to be a different distance apart, again, I get my ruler, draw the line above it, move my ruler down, hoping I keep it parallel, then draw the other line and make my parallel lines. Perhaps that's not quite so reliable. So I end up with what I call standard parallel lines. Even if I vary the orientation of my pairs of parallel lines, they're always the same distance apart. And that might lead to a misconception for the students as to the angles being equal because of the look of the standard parallel lines, rather than if the parallel lines are very close together or distant, still then not understanding that the same relationships apply. So a better way of constructing parallel lines is using a ruler and a set square. Put the set square on the ruler, draw a line along one of the sides of the set square, slide the set square along the ruler, and then you will have a pair of parallel lines as far apart as you want them to be. You can obviously set your ruler at any angle you want and move the set square a short distance, a long distance, as you desire, to get different looking sets of parallel lines so we can investigate the angles in all sorts of different situations. Now I can get pairs of parallel lines that are any distance apart and draw a transversal through them. With these three different sets of parallel lines, I can really look at the meaning of the word corresponding. This pair of angles are corresponding because they're in the same corresponding position. They're to the right of the transversal and they're both beneath the parallel lines. This pair, they're very close together, but they're both to the left of the parallel lines and underneath the transversal. They're in the same corresponding position. Exactly the same for this pair. They're to the left of the transversal, below the parallel lines in the same corresponding position. Hopefully, this will get students to really understand what we mean by corresponding, and you can do the same sort of activities for the other words as well. Taking that further then, as well as one pair of parallel lines, I can add in a third line and show that the relationships still hold, no matter where I put the third line. I can also introduce a second transversal. So I've got two pairs of parallel lines crossing. Again, I can look at the corresponding angles here. And I can see that if I move the transversal, that second parallel line, I've still got those same pair of corresponding angles. Equally, it's the same if I've got the second pair of parallel lines very close to each other like this. When I was doing that activity, I produced several parallelograms. Here are two of them. Both these parallelograms have got exactly the same angles because of the properties of the parallel lines. So we can use constructing parallel lines and transversals to understand the angle properties of special quadrilaterals. As well as parallelograms, we could also construct trapezia or other different quadrilaterals if we wanted to. Here's another construction. How can you draw a line through P that's parallel to the line segment AB? Have a think. Well, one way of doing it is by putting one side of your set square along the line segment AB, putting the ruler alongside the base of the set square, and sliding the set square along the ruler to point P to tell you where to draw that parallel line. So, in summary then, students can use rulers and set squares to construct parallel lines. That will help them to use parallel lines that are close together and far apart and see that the same relationships hold. We can then define and use and then later insist on the correct language from the students, what we mean by alternate, etc. Finally, we can link our understanding of quadrilaterals with the understanding of parallel line and transversal properties. That's it for this secondary snack. I hope you found something useful that you can take to your classroom and you'll be able to answer students' questions like, "Sir, what's a set square for?" Hope to see you again soon.